Welcome back. So today we'll talk about the sense of equilibrium. This is a sense that allows for you to be aware of where your head is at all times. Doing this, doing that. Wherever the head is allows for you to adjust your muscles to maintain your balance. Otherwise, you lose your sense of gravity and you tip over. So being aware of where the head is at all times is a critical sensory trait that we have. So let's figure out how it works. Okay, so this works because of receptors which are in the inner ear. If you recall, your inner ear has these things, these canals, 3 canals attached to a vestibule, attached to a cochlea. Okay, so here up here we have what's called your semicircular canals. Here is your vestibule, and this of course is your cochlea. So your canals are, the canals are responsible for detecting the head during angular movement. So they're good for angular movements, while the vestibule has in it 2 structures. An upper structure called the utricle, and the lower one called the saccule. Okay? And these 2 are useful for linear movements. Okay, so let's first discuss the canals, what roles they play in detecting head movements in an angular fashion. So we can let's make space for the moment. Again, 3 canals back over here. There's 1 canal here. There's another one right here, and one like so. Attach again to your vestibule and then the cochlea. So 1 canal is called the anterior canal, 1 is the posterior canal, and 1 is the lateral canal. Okay, so first, the anterior canal helps to detect movements of the head like this, like doing a flip, okay? Up and down movements of the head in a flip, so up and down, of head, front to back, as in doing a flip. Then the posterior canal, this one is side to side, as in doing a cartwheel. So doing this motion, this way, it detects it for you. That's the job of your posterior semicircular canals. And then the lateral canal, its job is to detect this movement of the head, that no motion, okay? So, rotation of the head. Rotation for the no motion, all right? So let's look at how these work then. So again, just in general, so no matter how you move, right? Something is firing to code the brain, tell it what's going on. So let's look at the structure of the canals, what it is about them that makes them able to detect movements of the head. So in your canals, let's draw 1 canal here. So here you have, again, your hair cells. Hair cells with a tall kinocilium, stereocilia like this. Okay. And these hair cells are in a gel-like structure called a cupula, like so. And then you have your canal. Okay, so your canal here and here. So this is your canal. And so in the canal, you have a fluid called endolymph. So in here is a fluid called endolymph. and that fluid can move in the canal. When it moves, it will hit the cupula. This gel is called a cupula. It will hit the cupula to bend the stereocilia. And when they bend, they create action potentials in your vestibular nerve. So this is the rule. So when these hair cells are straight up like this, so when you're not moving, like so, the hair cells are standing straight up. When this happens, this neuron will fire at a basal rate because some channels are open. These are all mechanically gated channels which are open to let some ions in to depolarize the cell, to release NTs, which cause an action potential in the nerve, as you know from before. And when you move in such a way that the hair cells, that the stereocilia, bend towards the tallest one, like so, then it fires more, like so. A lot more signals get sent to the nerve. And then vice versa, when it bends such that the stereocilia bend away from the tall one, like so, you fire less. So the brain knows what's going on depending on what these neurons are doing. If they're firing basally, it knows you're still. If they fire more, that means it means that you are turning your head in a certain way. And if they fire less, that means you're turning your head in the opposite way. That's how it codes for your movements, based on how the hair cells bend. Okay, we'll pause right here.